Welcome students, welcome back to the video lecture in power system planning. So we are studying demand side planning, which is a unit number 5 in power system planning course of Rajasthan Technical University. Here is the Google Classroom link so that you can connect with the Google Classroom code and you can access all the presentation slides, PDF notes and other video lectures from the Google Classroom also. The same video is uploaded on YouTube with Engineering College Banswara as our homepage. Here is my contact number and other details given. So you can connect me through email if you have any problem while connecting to the Google Classroom. Under demand side planning, we have covered computer aided power system planning, in which we have seen three important softwares: Wien Automatic System Planning Package, Electric Generation Expansion Analysis System version 9, and Integrated System Planning Package IS Plan version 4, where IS Plan is the most widely used power system planning package used in India and Thailand. So many of the objectives these listed here are 5 objectives related to generating plants, new, existing, transmission line, new, existing, can be solved using the linear programming formulations, and many of 7 constraints the software can took into picture. After that, we have seen what is wheeling. So wheeling is the transfer of bulk of energy or a block of energy from one utility area to another. Means it's just kind of buying and selling of block of energy between two utilities, where the interstate transmission lines operated by PGCIL is used to transfer the electrical power, and in this way the PGCIL collect a wheeling charge to wheel this block of energy from buyer to seller. The cost of the selling price at which the energy is sold is given by B. B is the price for the total block of energy, and PEX, that is the exchange power multiplied by number of hours, gives you the block of energy. For how much number of hours, H hours, the PEX, the power in megawatt, will be transmitted. After that, we have seen greenhouse effect. So greenhouse effect is required for the existence of life on earth. It makes earth warmer, and the long wavelengths that are infrared, which are re-radiated towards space during night time when sun is not there, after they get absorbed by the earth's surface during the daytime, they get trapped into the earth atmosphere due to CO2, water vapors, methane, and makes the earth warmer so that the life can exist on the earth. Now, due to pollution and increasing carbon dioxide level in the atmosphere absorbs much of these infrared rays, and thus making our planet not warmer but hotter. So in this way we can compare a human influence on the greenhouse effect. So natural greenhouse effect is very important, but due to increasing greenhouse effect or intensified by the humans, more radiated heat is absorbed in the atmosphere, which makes our atmosphere as hot, due to which we have certain types of impacts on our environment, like global warming, then disturbances in biological systems, rising sea levels due to melting of ice caps, polar ice caps, sukha, that is drought, and heat waves. There is an increased probability and intensified heat waves due to getting hotter when the earth get much hot. So extreme weather events like hurricane and tsunami will occur, and also there will be spread of diseases due to acidification of the oceans due to acid rain. Today we will see what is the technological impact. So sector by sector we will see how much and which sector are contributing to greenhouse gas emission, and thus uh, doing a job of increasing the level of these greenhouse gases and making it worse for the human existence. So number one is power stations. These power stations approximately have a percentage of 21.3% of to put greenhouse emission or greenhouse gases into the atmosphere. Then coming to the industrial processes, it's 16%, and transportation fuels for used for transportation are about 14%, and then agricultural byproducts, that is 13%. So approximately 13%, approximately 10%, the value of 10% land use and biomass burning, that you can know, agricultural waste and etc., residential, commercial and other resources. Then we have fossil fuel retrieval processes and distribution, means the production of petroleum products, agricultural byproducts, transportation fuels, industrial processes and power stations. So these are major components that are contributing to greenhouse gas emission. Also there is waste disposal and treatment, which contribute to 3.4%. So this is the approximate pie chart given here, which tells about which sector is or which technology is impacting in annual greenhouse gas emission, and this is a sector wise data. After that we have seen insulation coordination. So insulation of the equipment to be protected must be have a higher value than the protection level voltage of the device, represented by B here. IS standard 2026 we have seen for line to line voltages adopted for nominal system kV and maximum operating voltage. After that we have over voltages, and we have seen over voltages may be considered as external and internal, where external lighting, NEMP, NNEMP and other transient, temporary, steady state over voltages. After that we have switching surges, contamination and pollution, which are mostly the criteria for insulation design for a extra high voltage line and above extra high voltage, that is ultra high voltage lines. After that, here we have seen that for a 220 kV system with a maximum operating voltage of 245, the leakage distance required is 170 inches, which is approximately equal to 4.3 or 4.28 meters. That means the conductor coming to the tower will have a distance of 4.2 meter as its insulation, which is provided by string of insulators, and the leakage distance is the distance between the ends of the insulator string. Here this type of line or system of 220 kV has a switching over voltage level of 850, which is equal to the B value calculated here, that is 170 multiplied by 5, okay, or 3 to 5, any of the numbers will be considered. After that we have lighting over voltage. So lighting over voltage is given by this phenomena. So maximum value of the voltage that the system will handle are given, approximate values are given here, that the system must have an insulator string that is of 4.3 meters, then it can have a switching surge voltage level of 850 kV. That means the insulation that is provided by string of insulators will have a value of 850 kV as switching surge voltage level, and impulse lightning withstand level is of 1056 kV. Now we have reactive power compensation as our last topic here. So reactive power compensation is required in AC power transmission system, as active power needs to be supplied with reactive power because of the power factor. Reactive power does not contribute to energy consumed. This is a very important point. Only it is used to magnetize different type of devices, lines that are transferring electrical power. Then economical to supply reactive power closer to load. So it is very important, whenever the reactive power is required, it is economic to supply through or near to the load. Two major type of reactive power compensations are there: shunt compensation and shunt compensation or shunt capacitors are usually employed at substation level. This is very important. So in any transmission substation you can find these shunt capacitors or capacitor banks. These reduces power losses, they improve power factor, they increase the utilization of the equipments, they can have better voltage regulation, low voltage dips and reduce V drops. These are the important factors. Then nature of most of the load is inductive, consume reactive hours. Shunt capacitors provides leading reactive hours. Reactive power compensation can be provided at load and substation level or at transmission level. Also, voltage boost provided by shunt capacitor is consistent with the profile. So these are the important points, that reactive power compensation provided at load and substation level or maybe at transmission level. They provide leading reactive hours as of the there is shunt capacitors, and the voltage boost is consistent with the profile. Okay, so this is all for today's video lecture, and we will continue to next unit in the next video lecture. So thank you very much.